Hi everyone, my name is Jackson Bird. Welcome back to our second case study. Firstly, I want to apologize for my voice. I am recovering from an illness, so I apologize if my voice sounds scratchy or if I must pause for a sip of water. So today for my second case presentation, I will be reviewing Chapter 7's closing case called Bullock Gold Mining. I'm going to start by giving you some background information from the case, and I will be constructing and answering questions 1 and 2 that are associated with the case. So a quick overview of the case. Seth Bullock, who is the owner of Bullock Gold Mining, is evaluating whether or not to open a new gold mine. That's in South Dakota. Dan Doherty, the geologist for Bullock Gold Mining, has finished his geological analysis of the mine in South Dakota and estimates that this project will take roughly 8 years. This means that by the end of the 8 years, all the gold will have been collected from the mine. Given this information, Seth then asked Alma Garrett, who is the company's financial officer, to conduct a financial analysis of the new mine to help determine its profitability and help provide a recommendation on whether to open the mine or not in South Dakota. Alma then gave us further information in the case, which is laid out in our next slide. So Alma was able to estimate the initial cost of the mine at $650 million. And with the help of Dan's information he provided, she was able to project the revenues and expenses of the project. And then Alba was able to also estimate that at the end of those 8 years, there will be costs associated with enclosing the mine and reclaiming the area surrounding it, which would put the cash flow for that year at $85 million. The table down below or in the slide shows the expected cash flows each year from the mine. So if you see, we have year 0, which is that initial investment of $650,000, and then we've got the 8 years that it's going to take for us to collect all the gold from the mine, and then that closing cost of that $85 million to help close out the mine and reclaim the area. In the case, Alba also provided us with the knowledge that Bullock has a 12% required return on all of its gold mines. So you keep that in the back of your mind. So now that we have all the background information and the additional information provided by both Dan and Alma, we're going to move on to the questions. Question 1, which is more of an instruction rather than a question, but it asks us to construct a spreadsheet to calculate the payback period, the internal rate of return, and the modified internal rate of return, and the net present value. Question 2 says that based on our analysis, should the company open the mine or not? Now, we'll first work on the calculations, and then we'll readdress the question on whether the mine should or should not, or whether the company should or should not open the mine. But we need to keep the question in mind while we're working on these calculations, because the answers that we get from the calculations are going to help us provide the information we need to give our answer. Firstly, we're going to look at finding the payback period. Payback period shows the amount of time for a project or an investment and the cash flows that equal the initial cost of the investment. It measures how quickly an investment can recoup its costs. And then to calculate this, we're going to use that table that Alma provided, but also add a column on there, which is that cumulative cash flow. Cumulative cash flow is calculated by using the previous year's cumulative cash flow and then adding on the current year's cash flow. So for example, in year 1, you'll see that we took the $650,000 initial cost, and we then added the cash inflow of $125 million, which left us with a cumulative cash flow of $525 million. And then you continue on those calculations down the row, and obviously in year 0, you're just going to use that initial cash investment as the cumulative cash flow. Once you have the calculations, you'll find the period with the last negative value, So I have that highlighted there in the table. So in our case, this would be year 4. And this tells us that at some point between years 4 and year 5, we will have reached our payback period. So from here, we're going to divide the cumulative cash flow of that 90 million and divide that by the 115 million. And then we'll add on the 4 years. And with that, that gives us a payback period of 4.43 years, which is about 4.5 years for the company to recoup its initial costs for this project. So the next item we need to calculate is the internal rate of return, or the IRR. The internal rate of return used to estimate the profitability of potential projects or investments. It does so by almost working backwards. It calculates the rate by setting the NPV, or the net present value, to 0, and then working backwards to find the rate. In the spreadsheet, this is easily attainable using the IRR formula function in Excel. To do that, you would just enter in equals IRR and then open parentheses, and then you'll select the cash flows that you're using. For this instance, I'm going to use the full time it takes for the project, so that would be year 0 all the way to year 9 for the closing of the project. Using that formula, we get an internal rate of return for 17.08%. We're going to keep that rate in mind as we move on to our other calculations. Our next calculation we've been asked to find is the modified internal rate of return, or a modified IRR. And basically, a modified IRR is similar to an internal rate of return because it also is used to measure the profitability of a project or investment, but it does so by modifying the cash flows based on the return or required return rate, which in our instance is that 12% that we were provided. From there, you just do the same calculation of setting the NPV to 0 and then calculating the rate. On a spreadsheet, we can again use a function formula, this one being MIRR, and you don't even have to modify the cash flows yourself. That formula function will do it for you. The formula looks similar to the IRR formula, where you're just using the equals MIRR, open parentheses. You're going to use those cash flow years 0 through 9, like we did with the IRR, and you're just going to add on that 12% at the end of the formula. Once we've calculated that in our spreadsheet, we would have received a calculation of 14%, and that would be our modified internal rate of return. Again, we'll use that rate to help us answer the big question if we should open a mine or not. But first, we have one final calculation. Our last calculation, we're asked to create the net present value, or the NPV. The NPV is used to calculate the current value of a future stream of payments from a project or investment. Similar to the IRR and the modified IRR, it is used to help measure the profitability of a project or investment, but it does so by comparing today's value of future cash inflows to its costs. To calculate NPV on a spreadsheet, you would want to use the NPV function and use the required rate of return of 12%, and then you'll enter in that cash flow from years 1 through 9. Then you'll close that parentheses and add on the cash flow from year 0, which in our case would be that negative 650,000. Excuse me. This calculation gives you a net present value of 117,713,406 and some change, but we're going to round it to that number. Now that we've completed our calculations, we can take the information we've gotten from our analysis and proceed to answer on to question 2. So returning back to question 2, we're asked that based on our analysis that we just did, should the company open the mine in South Dakota? So we're going to take a look at all of our information. Looking at the net present value that we just calculated, we see that it is a positive number, and that indicates that our estimated returns will be greater than the initial costs. This generally means that the project or investment is worthwhile and profitable. Now, looking at our internal rate of return and our modified internal rate of return, we can tell that both rates are greater than our required return rate. This also shows that based off of our projects, our returns will exceed the cost of capital. So to answer the question, based off of our analysis of the NPV, the IRR, and the modified IRR, this project is financially viable and the company should open the mine. Now, there are other non-financial aspects that should be considered, such as operational capabilities, competitors, and even external regulations. But as for the financial viability of their project, the company should go ahead and open the mine. So that concludes my presentation for today. I hope you guys enjoyed it, or at least you learned something from it. Thank you for watching, and have a great day.